Okay, algebraic approach. Second method to find the domain and the range of the function. Okay, rational function. Y here equals to the 4 over x minus 1. First you find the domain of the rational function. Y here only define when the value, Y here defined for all the value of x except the x here, x equals to 1. Okay, first you let the denominator of the function x minus 1 here, you let equal to 0 and find the value of x. Okay, you let the denominator of the rational function x minus 1 equal to the 0 and you find the value of x. X here equals to 1. So domain of the rational function here defined for all the real numbers except the vertical asymptote. Yeah. So value of x here equals to 1, the vertical asymptote of the rational function. Okay, and you can write down the answer here in a solution set. Okay, or answer you here in interval notation. Yeah. So your interval notation. So answer you is all the real numbers, negative to the positive infinity, except the vertical asymptote. Okay, so vertical asymptote here at the x equals to 1. So from the left of the function, from the negative infinity. So write down here, negative infinity to x here equals to 1, unions 1 to the positive infinity. Okay, settle. Domain of the function. And then you find the range of the rational function. Write down the equation. Write the equation with x here in terms of y. And then you find the range of the function. Okay. Okay. Range of the function here. All the values of y except the horizontal asymptote. Okay, horizontal asymptote. Y here equals to the 0. Here is a HA, the horizontal asymptote. Okay, you check the solution. Okay, first you let the rational function y here equals to the 4 over x minus 1. And you write the x here in terms of y. Okay, x here in terms of y. X minus 1 equals to the 4 over y. Okay, so you let the denominator of the function here equals to the y. And x in terms of y, x equals to the 4 over y plus 1. Okay, and this rational function defined for all the value of y except 0. Okay, this one you put, this one is for all the real numbers. Okay, so value of y here for all the real numbers except 0. Yeah. And when you substitute 0 here into the function, 4 over 0 plus 1, answer you here equals to the infinity. Yeah. So you write down the range of the function, all the real numbers, all the value of y, except the 0. This answer in solution set. Okay. Or second option, you can write down the answer here in interval notation. So you find the range of the function from the bottom us, negative infinity, and y here equal to 0, and unions 0 to the positive infinity. Okay, settle. Okay, question 1. Find the range and find the domain of the rational function and the absolute value function. Y here equals to the modulus x plus 1, and you find the domain of the function. Y here defined for all the value of x, and domain of the function is all the real numbers, negative to the positive infinity. Okay, and B, you find the range of the function. You write down the equation in x here in terms of y, and find the range of the absolute value function. Okay, you check the solution. Okay, question 13. Find the domain and range of the following function using the algebraic approach. Fx equals to the modulus x plus 1. Yeah. Okay. First, you find the domain of the absolute value function. So, domain of the absolute value function, all the real numbers, and df here equals to the negative to the positive infinity. Yeah. Okay, settle. Domain of the absolute value function. And then you find the range of the absolute value function. First, you write down the function here, modulus x plus 1, write down in a piecewise. Yeah. First part of the function, fx here equals to the x plus 1. Yeah, the positive function. So you write down the function here. Okay, first part of the function, positive, fx here equals to the x plus 1, and the domain here greater than or equals to the negative 1. And second part of the function, fx here equals to the negative x plus 1, and domain here less than negative 1. Yeah. And then you find the range of the function. Okay, first part of the function, when fx here equals to the x plus 1. Okay, so you let the y here equals to the x plus 1, and write down the x here in terms of y. So x here equals to the y minus 1. Okay, and domain of the function, x here greater than or equals to the negative 1. So here is the domain of the absolute value function. Okay, and then you replace the value of x. You replace the value of x here. Okay, you replace the value of x with the y minus 1. Okay, so the left hand side of this inequalities, y minus 1 greater than or equals to the negative 1. Okay, and you solve the linear inequalities, y here greater than or equals to the 0. Yeah, and the range of the function start at the origin, 0 here to the positive infinity. Okay, here the range of the function, and the second part fx here equals to the negative x plus 1. Okay, and then you let the function y here equals to the negative x plus 1. Okay, and here equals to the negative x minus 1. Okay, negative x minus 1, and domain of the function x here less than negative 1. Okay, so here these terms x equals to the negative 1, you replace, you put here. Okay, so the left hand side of the linear inequalities, negative y minus 1 less than negative 1. And then here, negative 1 plus 1 equals to the 0. And the right hand side, negative 1 plus 1 here equal to the 0. So you put the operation here, plus 1. Okay. And answer you here, negative y less than 0. And then you change the signs of inequalities. You times negative 1. And then y here greater than 0. Okay. So range of the function greater than 0. So Rf here equals to the 0 to the positive infinity. Okay. Okay, you check the first function, the range of the positive function fx equals to the x plus 1. Range of the function here include the 0 to the positive infinity. And the second function, Rf here equals to the 0 to the positive infinity. Okay, using the open intervals. Okay, and answer you here include 0. Okay, you check the sign. Here is the circle. And here 0 here using the empty circle. Okay, so you combine dense and empty circle and answer you here range of the function 0 to the positive infinity using the semi-open bracket. Okay. Okay, square root function, domain of the function when the y here equals to the third x minus 9. So domain of the function 9 to the positive infinity. Method here using the square inverse height. Okay, using the square inverse height, you let the function fx greater than or equal to 0, and then you factor you square in both sides, and then you find the value of x here. Yeah, and domain of function. So you write down in the interval notation. Start at the 9 to the positive infinity. Okay. Okay. Question B. You find the range of the square root function. You write down the equation here, x in terms of y. So x here equals to the y squared plus 9. And you find the range of the square root function. Okay, question 14. Find the domain and range of the function using the algebraic approach. Set x minus 2. Okay, so you find the domain of the function. First, this function, square root function, only defined when the value of fx here greater than or equal to the 0. So you let the function fx here greater than or equal to the 0. Okay. And set x minus 2 greater than or equal to 0. And you square in both sides. And here left hand side here equals to the x minus 2 greater than or equal to the 0. And value of x here greater than or equals to, yeah. The domain of the function start at the 2 to the positive infinity. And you write down the answer here using the semi-open bracket, yeah, 2 to the positive infinity. Okay, and you find the range of the square root function. The range of the square root function, you let the y here equals to the third x minus 2. Okay, and then square in both sides. Okay, y square equals to the x minus 2. And you write down the x here in terms of y. X equals to the y square plus 2. Yeah. Okay, and x here defined for all the value of y. Okay, so here you check. You check this function. X equals to the y square plus 2. Okay, you just try an error. So first value you substitute into the function when y here equals to the negative 1. Negative 1 square plus 2, answer you here equals to 3. Okay. Second value y here equal to 0 and plus 2, answer you x equals 2. And then here positive value y equals to 1 and answer you here x equals to the 3. Okay. So the value of x here defined for all the value of y. You substitute any value of y, positive 1 or negative 1 or y here equal to 0. So x here defined for all the value of y. And you check the definition of the square root function. This function only defined if when the fx here greater than or equal to the 0. Yeah. So you start from the 0 here. You pick this value. Y equal to 0. Okay, define. And y equals to the 1 defined. 2, 3, 4, 5 to the positive infinity. Yeah. So final answer, range of the function include 0 to the positive infinity. Yeah. Okay, at pen 2, composite function. Okay, here example of the composite function. Gx equals to the 2x plus 3. And fx here equals to the x squared. So you find the composite. G of x and answer you here equals to the 2x squared plus 3. Okay, question 15. Given the linear function fx equals to the 5x minus 7 and gx here equals to the x plus 4, and you find the composite function f or g, and question B you find the g or f. Okay, question A. You find the composite function f of g. F of x plus 4. Okay, composite function f of g equals to the f of x plus 4. Okay, so here is the function gx. Okay, and fx here equals to the 5x minus 7. Okay, so 5 times x plus 4 minus 2, 7. And here equals to the 5x plus 20 minus 7. And composite function f of g equals to the 5x plus 13. Okay. And question B, you find the g of f, or here equals to the g of fx. Yeah. Gx equals to the x plus 4, and fx equals to the 5x minus 7. So here, the linear function 5x minus 7. And 5x minus 7 plus 4, and here equals to the 5x minus 3. Okay, question 16. Given the quadratic function gx equals to the x squared minus 3, and you find the fx. If the composite function g of fx here equals to the x squared minus 4x plus 1. Okay, first function gx here equals to the x squared minus 3. Here is the quadratic function, and you find the fx. Okay, given the composite function g of f equals to the x squared minus 4x plus 1. So here the left hand side here the composite function, and equals to the f of x squared minus 3. You check this function. Okay, and then you find the fx. Yeah, x squared minus 4x plus 1 and plus 3, and answer you here equals to the x squared minus 4x plus 4, and you factorize x minus 2 times x minus 2. Yeah, and f of x squared here equals to the x minus 2 square, and this function fx equals to the x minus 2. Yeah, settled. Okay, question 17. Given the linear function gx equals to the 3x plus 2, and you find the fx. So given the composite function f of g, okay, and linear function gx here equals to the 3x plus 2, and you find the fx. Okay. Okay, check the solution. Okay, first the composite function. F of g equals to the 9x squared plus 12x plus 10. Yeah. And here you find the f of g, f of 3x minus 2. Yeah, yeah, the left hand side. F of 3x plus 2 equals to the 9x squared plus 12x plus 10. And you let the u here equals to the 3x plus 2. Yeah. And then write down the x here in terms of u. x equals to the u minus 2 minus 3. Okay, this one in terms of u. Okay, and you find the fu. So fu here equals to the 9u square plus 12u plus 10. So you replace the x here, you replace with u. Here is 9u square. And here equals to the 12x and then plus 10. Okay. So the value of u here equals to the u minus 2 over 3. You substitute. Okay. Yeah. So 9 times u minus 3, 9 times u minus 2 over 3, and plus 12 times u minus 2 over 3, and plus 10. And then you solve the equation, and here equals to the 9 over 9 here equals to the 1. Yeah. And u square minus 4u plus 4 plus 4u minus 8 and plus 10. Okay. Now, so you here fu equals to the u square plus 6. And you replace u here with x. And fx equals to the x square plus 6. Okay, settle. Questions 2.